Embed has never been so exciting. It's life-saving. It's life-changing. It's dream-making. And it all starts with this chip. A small and mighty computer the size of a credit card, with embedded chips and processors, enabling our passion and curiosity to solve anticipation of a problem, mitigate risks, and create solutions that improve business and life. The potential that lies behind executing dreams is so tremendous. If we fail to realize them, the responsibility lies solely on us. So dream away. Be great. Enclustra. Embed with us.
Maybe I've heard the saying, give a man a fish and he will eat for a day. Teach him how to fish and he'll eat for his whole life, right? And so this presentation here today is not about giving you a fish. This is about maybe helping you to think in the terms of what does fishing look like, and that's why I've chosen this title, Multi-Project Design. So typically, our life is quite packed. And if you're an engineer, you've got a lot of tasks, you've got a lot of pressure sometimes you have to deliver. So you tend to focus solely on the task that is before you, because you have to get it running, you have to deliver the results. But sometimes it makes sense to take a step back and look at the bigger picture, look at, okay, what are we going to do after this? What is our next project, our next design going to look like? And how can we build a system, let's say a base platform that will enable us to move to the next system quicker, to reuse more of your already written code. That's a big investment. And also to make the maintenance less costly, because that's a key factor. So this is my starting point, that I would like to think about what will engineering look like in about 5 years from now. So first of all, I think we will have enough chips available at that point. We hear about all those factories being built all over the world, and one day they're going to produce, hopefully at the same cost, but they will output all chips. So in 5 years, we will not be talking about a shortage of chips, but we will be talking about a shortage of resources. That is already reality in a lot of industries. Where I come from in Europe, this has been going on already for 5 or more years. So that is the shortage that we have to deal with. How can we do the same work with less engineers? Then, I think in 5 years, the module vendors, they will take over a large part of the responsibility of helping people design in a specific technology. We see that the chip manufacturers are very, very busy with developing the great technologies that they have. But when it comes to actually helping customers to get this really designed in, I think we will play a more and more important role. Fourth point is that the software cost is increasing at a rate that is incredible. So software is probably already 10 to 1. If you look at a typical embedded system, it's probably 10 times more than the hardware itself. And that's probably going to increase. Maybe 10 to 1 is going to be 20 to 1 in 5 years. So we have to think about a way to do more with less, because the software is going to get a lot of the resources. And on the hardware side, on the FPGA side, we have to do more with less. Yes, and also it's not just developing the software, but the software maintenance. If you think that every embedded system has a Linux, and just to maintain a Linux with all the the new kernels coming, and all the new tools coming, and just keeping it up to date in a company that can cost quite a lot, can keep maybe one or two people busy their whole year just working on that system. So today, in my presentation, I want to focus on platform technology requirements and specification. I will also talk a little bit about why and about the benefits and the implications to the design flow, but this middle part will be the main focus of my presentation. So the question is, why should we build something based on a platform? And there's a lot of reasons to do that. And the first one is to manage the complexity, because the chips are getting more and more complex. The SoCs, they are not just the sea of gates anymore. They are, I used to think when I started we were told that all you ever need was a flip-flop and an AND and an inverters. And then you can basically build everything out of that. And yes, that's still true, but the subsystems have become more and more complex. So you need to manage that in some way. Then you still want to be on the market in a reasonable time. That's very important. So you can get your return on investment. Yes, the reduced maintenance cost, as I said at the beginning, that might be a very big factor. We might not even see how much goes into that, because sometimes the maintenance is just on a different budget than the development, right? So some of us might not even care so much about the maintenance costs, but for the whole company, it's actually a very, very important factor. And yes, so we are all in the situation where we have multiple stakeholders, and we want to keep them more or less helping, because when they are happy, we can have more fun in life. And having fun in life, as it was told in the beginning, for me, it means that I can go on my mountain bike, I can train in the Swiss Alps, I can take part in races, I can push myself to the limit, I can enjoy the wonderful landscape of the high mountains, and make new experiences of what it means to overcome difficulties. Yeah, what do product managers want? We all have to deal with product managers, and they tend to always want something that we don't have yet. So first of all, they want it always to be twice the speed, right? So twice the speed, or having maybe the double number of video inputs and outputs. And so it's always a step higher. They want additional features, and usually they learn about what the additional features they want when we're already halfway done, or maybe 90% done. Then they come up with this new feature that is just very popular on the market right now. And why can you not do that as well? Have the cost? Yes, of course, that would be nice. But put the product on the market this year. It's always this year. So even if it's October, it's still this year. And then comes the really the worst topic of all, which is customization. Then you have these customers, right? So they are really sometimes quite tricky, right? To please. They say, well, you have a great product, but if you could do this little thing, maybe just attach that one interface that, for us, it's still very important. Even though it's been around for 50 years, but we will never get rid of it. So can you not do that with your system? That would be really nice. Then it would be the perfect product. Then you have the managers, right? The managers here are a special breed, right? They think differently. They talk a different language than we do. They talk about product output, yeah. They want to reduce, of course, they always want to reduce cost, no matter what it is, always need to reduce cost. And at the same time, they want to be always on the leading edge. Everybody wants to be on the leading edge, and that's, I would maybe compare it a little bit with surfing. I know surfing is a big topic here in California. I myself, I'm not a big surfer, but I tried it a couple of times, and it's just so nice if you can see somebody being like on riding on a wave, right? I'm like, okay, that's where I want to be. And so I get on that surfboard, and I find it so impossible to actually get on that wave, right? But yeah, I know if I try hard enough, I can be there. One day I can be riding that wave and enjoy it. But it's not as easy as it looks, right? It looks so easy. Yeah, jump up on the board, and then I got the first wave and it knocked me off my board backwards, and I did a backflip, which looked quite nice, I'm sure. But yeah, that's not the point. So leading edge, right? Less people doing just software updates, yeah. And yeah, we all want that. Who wants to do software updates, huh? It's a pain. You don't want to do that. And we use more code. Of course, the managers, they want, if they have invested something in something, they said, we have to reuse that, right? But we didn't think about reuse when we wrote it, to be honest. And actually, our new system is completely different. We're using a different technology. So it's not that easy. It's not that easy. How can we keep all stakeholders happy? I think what I'm talking about is to think about these things before we start. Because once you're on the road, once you're decided for a certain approach, you have to somehow stick with that. So think about the long-term design strategy, not about the next system and maybe the follow-on, but about the next 5 years or 10 years of designing systems. And it works when you have a platform, when you think with a platform, when you don't think with how many transceivers am I going to have, and how many lookup tables do I need. But when you think with a platform where you basically say, okay, I have these block level functions and I need to do them, and I need just a platform underneath that is able to do that. So as my son taught me, Dan, you should not work so hard, you should work smart. Right? And because I'm still the generation, we get up early in the morning, we go in the office, we work hard, and if it doesn't work, we work a little bit harder and we get the job done, right? And my son says sometimes I think a little bit and I do it completely different. And I save 3 days by doing it completely different. And I think we can learn something from that generation. Platform requirements. What are, if we look at the platform that we want, what does it need to be able to do? So first of all, the hardware needs to be scalable. What I mean with scalable is I basically want a platform which gives me a little capability for a little money and a lot of capability for some more money. And I also want to have flexible interfacing, because that's the thing, we don't know exactly what the interface is going to look like. So we want to be able to pretty much attach everything, right? And then comes that one customer who has his special interface, and then we want to also be able to attach that to the same platform. We want to be able to upgrade the system. So if the next technology comes available from ALE, as an example, we don't want to redesign the whole system. We want to basically upgrade to the next technology and get the benefits without having to invest a lot of money. And of course, the system should be capable. And I still am convinced that the FPGA has some capabilities that are just really beyond what anything else can do. Like we have very, very low latency with an FPGA. I just haven't seen anything else except for an ASIC. Of course, if you can afford an ASIC, you're always going to be ending up doing an ASIC. But also on the way to get there, you're probably going to use FPGAs to get to the ASIC. Then, of course, the massively parallel processing. It was mentioned in the talk before me. That's just something that is really, really very capable. So if you have a problem which maps perfectly on a specific processor architecture, it's going to be quite efficient on there. But if you're dealing with an analog world, with signals that are very bad when they come in, and then you have to make out of that something. Then you need that massively parallel processing that you will get from a FPGA-based system. And of course, deterministic. What I always liked when studying FPGAs, and that's quite a long time ago, was that you could actually do exactly what you wanted, and you would know exactly what you were doing with an FPGA, because cycle for cycle, you know exactly which flip-flop is on which stage, and for me with software, that's not always so easy. Firmware. On an ideal platform, I would want my IF blocks that I've written to be just basically plug and play on the next system. I want it to be very portable. I want to have an IP that I can really reuse without having to rewrite of it. And also on the firmware, I want to have some capability for true real-time processing. So I mean that's also just possible with the FPGA. I mean, we have real-time processors which are pretty good, and they're easy to program, but they're still in a range where our train has already left the station, I would say, when it comes to FPGA. And software, a standard operating system just gives you a lot of benefits, like a Linux. A Linux is, quality-wise, it's very good today, and you get the benefit of having all the drivers to come with it, and a lot of tools, a lot of software to come with it. So there's definitely a huge advantage of using a standard operating system. You want to have a real-time operating system on the side, if necessary. And of course, you want to have a very efficient interfacing between the operating system and your programmable logic, the FPGA. You want that to be efficient when it comes to latency, and you want that to be efficient when it comes to bandwidth, that you can do a lot of data. So this is just, let's say, our block schematics, very, very rough, So I call this the universal platform. That's what I want. I want to have peripherals at the bottom, anything that I can attach, that I can't attach to, but I have the universal interfaces to attach to. I mean, programmable interfaces, so standard interfaces, of course, included, but also custom interfaces. Then I want the universal processing. That means I have my serial processing, my real-time processing, I have my massively parallel processing, I have my signal processing, and I usually have libraries there that I can use, so I don't have to write everything from scratch. And then on top of that, I have my standard operating system, Linux, and maybe also free RTOS, and then the application should sit on top. That would be the ideal world, right? And if let's say if really truly 90% of, or maybe 95% of the innovation happens up there on the application side, then really that should be easily portable from one system to the next system. Okay. How to select the right platform? I said that, scalability is important. I would also say flexibility is important, and roadmap is important. And when it comes to scalability, I have been on an adventure, a trip or excursion one time, and then they hand out these rubber boots because it gets a little bit messy from time to time. So I asked, well, what size do you have? And they tell me, well, we have two sizes. We have too big and too small. Which one do you want? And I think I ended up with the too big, which was just very uncomfortable because you were constantly sliding in the boots. So we don't want that, right? That's not what we want the system to be like. We want the system to scale, like, I would say, like a shoe, right? The shoe is never perfect to my foot because every foot is different, right? But they make them in sizes which are pretty good. Once you have broke them in a little bit and walked 100 or 200 miles with them, then they're usually quite good. You should, if not, throw them away and buy another pair. So at Enclustra, we have designed different form factors. We have designed different form factors to give you the scalability. And the important thing is that even the different form factors, it's still the same platform, basically. So our typical working horses right now are Mars and Mercury. The Mars is a sodium-based form factor. It uses the sodium 2 connector, which is used for memory in laptops. And the Mercury is also connector-based form factor, which uses 2 or 3 connectors. These are high-res connectors that we have used here until now. And so those are very good scaling form factors, but because they were not able to accommodate the biggest chips, and because the connector speed was not able to cover the next generation of transceivers, we have developed the Andromeda form factor. So this is our form factor, which is the most scalable form factor around in the industry. And then because for some applications you want it to be really small, we have our form factor called Pluto. And the important thing is what you see here, these are all songs with the same technology. So it's a Sync UltraScale Plus, the so-called MPSOC. It has the same memory chips, it has the same eMMC chips, the same PHY chips. It's essentially the same platform, even though you have different form factors. And if you look at the product offering from AMD Xilinx, if you look at the Sync UltraScale Plus here on the top, you see these are the different devices. So the dies. So you start at SEGU1, goes all the way up to SEGU19, which is the biggest, and then here you have the packages starting at the 484 package and going all the way to a 1924 pin, very, very large package. And if you look at those available devices, with Mars, we were able to cover 3. That is not very, very scalable. Then with Mercury, we were actually doing pretty well. We were able to scale from the SEGU1 all the way to the SEGU15, covering 3 packages, and then they got too big for the form factor. And with Andromeda, we're actually able to cover all the way from the SEGU1 up to the SEGU19, so we can cover the whole thing. And then Pluto fills in a little gap that's still with the small devices. And so basically we have the whole field covered with essentially the same platform. Flexibility. When I talk about flexibility, I'll take the Andromeda as an example, because we have designed it to be a very flexible form factor as well. So first, it comes in 4 sizes. So if you look at the 6 connectors here, you can have a module with just 2 connectors. You can have one with 3 or 4 or 6. And then also the SOM has 4 sizes: small, medium, large, and the V is something which is especially for VPX systems design, so it's a little bit longer and not so wide. So here we have various FPGA sizes available, and if you look at a device offering from AMD, they usually give you a factor of 2 from scalability. But with our approach with Andromeda, we actually have a factor of about 15 from the smallest to the largest FPGA. So we have a very, very large scalability there available. Then I/O standards, of course, it has lots of different I/O standards, lots of different I/O, and the connectors, they are able to go up to 112 gigabits per second PAM4. So to the next generation of I/O, of serial transceivers. So that is future-proof. Then we have lots of extras. We have flexible memory values. So when we build a SOM with an FPGA, we can either give you more I/O, or we can put more memory on there, like a second memory on the PL side. So if you have an application which is particularly memory hungry, you need to buffer large amounts of data, then a second memory comes in very, very handy to buffer the kind of data. Right. And then in addition, some we could not use that RAM, but give you more IOs. That's for those who need more IOs in their system to maybe getting more data from ADCs or so whatever. Another thing is that Andromeda form factor is also used for our RFSOC module. We have our first RFSOC module back here. I will talk more about that in a minute. But it essentially also uses the same connector layout as the Andromeda, and then it has additional connectors for the analog front end. And this is a form factor which is built for longevity. I would expect it to be around 30 years or so in that range, because we have just started with this and we are building all of our new generations of songs based on this form factor. Yeah, we have a roadmap for the Andromeda form factor. Right now, we're still working on the Zinc UltraScale Plus modules. So we have two modules which are available right now. So XQ65 and XQ90, which have some of the larger size devices. Then there's a smaller one coming. So this should be about two size. The difference between size, this would be a small, this would be a medium, but this is a large Andromeda form factor. And so there's a whole product table starting at the XQ30 going up to the XQ90 with the different Xilinx devices, which basically gives you that scalability that I have been talking about, and the flexibility when it comes to memory and when it comes to I/O. Down here, you start at about 156 IOs, and it goes all the way out to about double that number, or even more is possible. Roadmap. Yes, what if the next generation comes out? What about Versal AI Edge? Is that going to be a completely new design, or is it going to be compatible? And that's the thing. It's basically not going to be a new design. It's going to be the same form factor, the same pin out of the form factor. So in best case, you can just plug out your Zinc UltraScale Plus song and swap in a Versal AI Edge song, and you have a system which is upgraded. And then I also want to talk a little bit about the printer form factor. So this is something for products which need a smaller technology and also a cost-optimized technology. These are the smallest available devices. From Xilinx, here is the Pinto XZU20. It has the ZU3 in the info packet from AMD, and it's still a very powerful architecture. It's the same architecture as is in the bigger devices, but at a very, very small form factor. And also, I said this is going to be cost optimized, so we expect that we will get customers who use tens of thousands or maybe even hundreds of thousands of these in their product, because that's what it's designed for. It doesn't have a connector. It's basically, it's just solder on module. So you insert this in your production process and you solder it on your board and you're basically finished. Okay. Then, yes, I said we have our first RFSOC module here. It's back there on display. If you want to look at it, please look at it. Don't touch it, because I get in big trouble, because I more or less stole it from engineer or borrowed it, and how we say. So I have to bring it back this week actually, or I get in trouble. So yeah, you probably know about the RFSOC technology. It's basically a Zinc UltraScale Plus technology with very fast digital to analog converters and analog to digital converters. And so it's a very capable technology when you wanna do 5G or software-defined radio at very high speed and radar applications. It's pretty much designed for those kind of applications. And it's, from our perspective, from the Linux perspective, it's again about the same platform you have. You just have those analog to digital converters and digital to analog converters. Yeah, we have more modules that are planned on our SOC. So they're on the roadmap. There's a smaller one, and there's actually two small ones, but with different devices covering even more use cases. And then Versal AI Edge. Yes, there is plans for Versal AI Edge. We're working on that right now. And there's going to be a great talk today from Kevin from AMD, and he's going to have a demo here. So he's going to be, he's either already here or he's going to be here shortly. And yeah, I see him waving. He's hiding behind that. Oh, yeah, Kevin, hello. Because so he's back there. He's showing a great demo with Versal AI Edge. What are the benefits of a platform design strategy? As I said at the beginning, it's it's more long term. It's more long term thing. So with the hardware, you can minimize your design and your redesign effort, because you can start with already a fully tested or fully proven system that you can just plug in. And if you do your next product, you basically just adjust that a little bit, or maybe even use the same baseboard for the next product. So you can really save here on hardware design and redesign effort. And when it comes to the flexible interfaces that I've been talking about, we recommend that you build yourself a library with your interfaces. So then it's easier to use it in the next system, and you don't have to do that every time by hand, but build the library and then reuse that. So remember, you have maximum portability of the code, because as I showed here with the Sync Autoscale Plus, it's even the same technology, it's even the same CLB technology and MOX technology, whatever. So you can just take one block and put it onto the smaller or bigger system, and it should work. It's just a question of recombine. When it comes to Versal AI Edge, that technology is slightly different, so it might need some adjustment there, but it's still, FPGA technology is still the same tool. You still have the Vitis tool or the Vivaldi tool that you can use, and that's a big benefit, having the same tool chain available, knowing how to use it, and having it deployed. Software, you can reduce your maintenance costs because you can have one Linux for different systems. And you can do upgrades at the same time. It's quite easy to automate that when you make configuration files for your different products, and then you can run those in an automated way. So cost savings are mainly we would say because of the product development, but then next in line is the maintenance. And of course, the customization. Customization is less costly. It takes less effort to maybe do a respin of your baseboard, because it's not as complex. It doesn't have the DR on it and all of those things. So it's easier to do a respin if you have a customer who says, no, I need it to be round instead of square, right? Some do that. And then, of course, when we look at the benefit of having a bigger market, getting a bigger market share, because you're actually there faster, and you can actually do more in the same time. That's probably the biggest benefit is just being more present in the market. I had one customer in the UK, and he said, well, we started using songs, and then everybody was happy. Our sales were happy because they were getting the products faster. Our marketing was happy because they got more products, and our management was very happy because we were actually getting new customers that we didn't get before, because we have big products. So high quality and longevity, all of that. If anything changes in the song, that you don't have to do a redesign. Now, if anything changes, we'll do the redesign and we'll send you the new version. We'll swap out a part, those tiny little parts that are basically doing not a lot, but you need them. And if you don't have them, you cannot build your boards. You don't have to worry about all of that stuff. That's all done by us. And then, make the implication to design field. That's maybe something, where we can give a little some tips. So when you start to do your design, don't go into the integrated details. Just stay on block levels. Just define the blocks as functional blocks, what they need to do, and then you can still decide with some of the blocks. Are you going to put that on a serial processor? Are you going to put that in the FPGA hardware? Because maybe you have some bits left, and then you can move some stuff to offload the processor for other things. So stay pretty much on the block level there. Do a quick functional prototype. I think that's very important. So AMD makes great boards, but we also make great boards which enable you to make a quick prototype. So we have baseboards available with all of our modules. You can use the SOM at the beginning in the standard baseboard, and you have like extension interfaces like FMC and stuff, where you can attach some cards that are available, maybe with that analog to digital converter or other things. So you can make a quick functional prototype, and then usually, if you have a bottleneck somewhere, or if you have forgot about something, then you will find out on that functional prototype quite quickly. And at that time, you haven't invested a lot of money in hardware design yet. Then you can start to develop your firmware and your software and your hardware in parallel. So you can do a baseboard for the SOM. You can write your VHDL code and try it out on the development board, on the prototype. And you can, of course, write your software, because it's on the highest level and it's quite generic. Yeah, as an example, how easy it can be to swap in a new module and to change something from one form factor to the other. We had this year we showed a low latency video demo. By the way, we have also 2 low latency video demos back there. We showed that at the Embedded World, and we told the team at the beginning it's going to be on a Mercury module, the XU8. And they started developing it on the XU8. And then the X765, the Andromeda, became available, and we saw, okay, that could work with the Embedded World. So let's do the showcase on the X765. Of course, then the engineers at the beginning, they were not so happy, because they said, well, it's a different module and we don't know, might not work. At the end, it took him 1 day to move from the XU8 to the X765. It took them 1 day. And to make things like that easy and possible, so we have adapter boards. So we use this adapter board. So this is on one side, it's a Mercury, and on the other side, it's an Andromeda connector layout. And so basically with this adapter board, if you already have a Mercury board and you want to try out an Andromeda board, you can use such an adapter board and try out the Andromeda module in your Mercury baseboard. So we make stuff like that to make it even easier to move from one form factor to the next, or maybe from one technology to the next, to help our customers. So the first steps here is one of those baseboards, the ST1 with a SOM on there. That is the X765 that we used in the Embedded World with the adapter board underneath it. So the first step would be get such a board. Just get such a board, evaluate it. Look, how good are the tools? Set up the tool chain. Look at all of our documentation. If you have anything, give us feedback. We have a very good support hotline. It's called support@enclustra.com. You write it, you get an answer from engineers in our headquarters in Zurich. So you get very, very good support. If you have feedback, please give us feedback. What is not good? What can we improve? We are really open to make our products better and more usable for you. Then make a plan for your own base platform. Maybe here you decide on the form factor that you want to start with. Maybe we would recommend starting on the Andromeda. Right now, if you're starting a new design, start on the Andromeda or on the Bluetooth. Get the design files here. What we do is for this board here, you can write us, we send you the whole Altium project for the space board. because we want to help you to be as quick as possible with your own export. So you can get the whole Altium designing. All you need to do is sign a one-page license agreement that you're not going to hold that against us and all of those things. Don't use it against us, please. But that should help us. It should help you to get up to speed. Then you have to think, what should we do in the house and what can we outsource? And this is where I want to. This is where I want to recommend our design services department, because we have about 40 engineers who work in design services and do nothing else but customer projects. Because sometimes the resources are not there, sometimes the pressure is high. Sometimes you just you think it's going to be cheaper if you do it with us, because we have the experiences. I mean, also with less cost. So you have to decide: are you going to do that in house? Are you going to do it out of your house? And then with the software, you have to decide on a build system. And I assume most of you know what I'm talking about. Maybe use a Linux Yocto approach or use your own build route. But the thing is, once you've decided on a build system, that you're pretty much stuck with it for quite a while. And so maybe you better think about it. I think going with the Yocto, because it's more of a standard thing now, is probably the safer approach. But if you really on Linux crack, maybe then you want to go with your own build rules system. And of course, select your software development tools. Yes, of course, on the further side, the tools are provided by the FPGA technology providers, and there you have lots of good tools available from AMD. So and we help. And as I said, we help because we are a one-stop shop. So we don't want to give you a fish. We want to teach you to fish. And ultimately, we want to actually fish for you or fish together with you, even do the fishing for you if you need to. So come to us. We can do any custom tailored system that you want. It's got to be embedded. It's got to be Linux operated. It's got to be FPGA enhanced. I mean, this is where we are strong at. We're also doing other things, but this is where we're really strong at. So if you goes in that area, we're definitely somebody that you should look at. And yes, at the end of the day, we work in processing solutions. So I already talked about the design services. The exciting thing about a company like Enclustra is that we don't just provide awards to our customers, but because we do those design services, we become part of their whole creation process. And that's really exciting because if I look at, there's so many different things that have been done with our products. Some of them are up in space, some of them are deeply on the sea, some of them are in minus 50-degree temperatures, or others are in plus 50 degrees temperatures. Our products are gliding, they're flying, they're whatever. You name it. There's almost no limits to what you can do with this technology. And just to be able to be part of that is to create something that's really a very, very satisfying task. So if you think we can be part of your creation process, that would make us really happy. And we would help you to get there faster. And at the end of the day, if we develop something for you, you own the IP. So that's how we work. So you get the IP, you can do with it what you want. This was pretty much everything that I have on store, except that I want to emphasize again that we are here now in the US. We are a Swiss company, but we have our US counterpart now, Enclustra Inc., and we have our first office. It is in the beautiful town of San Diego. And just been in the office last week. It's a very nice building there on West Broadway. And we are hiring currently. We're in the hiring process, looking for good engineers to do design services here very locally, to give you a very, very good support here if you're working with us. And we are very excited to see what's coming. Okay. You're Roland.
Embed has never been so exciting. It's life-saving. It's life-changing. It's dream-making. And it all starts with this chip. A small and mighty computer the size of a credit card, with embedded chips and processors, enabling our passion and curiosity to solve anticipation of a problem, mitigate risks, and create solutions that improve business and life. The potential that lies behind executing dreams is so tremendous. If we fail to realize them, the responsibility lies solely on us. So dream away. Be great. Enclustra. Embed with us.